All right, guys. So like I was saying, we're kind of trying to wrap up the last part of chapter 4. So this is kind of where we had ended, was with the theoretical probability. And one of the last things we had just talked about was basically how to work with the and or probabilities. And then, of course, we got into, just if you're looking at disjoint or overlapping kind of sets and what those calculations would look like. So I wanted to see a couple examples for us. Now, we had done the first two examples that I had, selected for us, numbers 2 and 4, but I had a couple more that I wanted to look at. So let's take a look at number 8 as our next example, just to make sure, we're comfortable with these theoretical probabilities as well. So as you can see for number 8, we are talking about basically you are rolling two 6-sided dice, and the idea is, how do we calculate probabilities based on that? So the first one is asking us, you are rolling two pair 6-sided dice, and what is the probability of getting a sum greater than or equal to 7? And then for part B, we are talking about getting an even sum or a sum greater than 7. So you can see both of these are using the or connector, basically. So let's take a look at what this would look like. Now, for this one, since we are talking about rolling two fair 6-sided dice, the sample space we had seen, and I'm trying to think if it was in this section or the previous one. I think it's this one here. So we'll definitely need this little sample space that we have over here to help us out. Okay, so we'll kind of come back and forth between that. So the first question is asking you, what is the probability that you are going to get a sum greater than or equal to 7? And again, if you guys wanted a link to this document, let me send that through chat to you guys. Okay, so we're talking about a sum greater than or equal to 7. So we definitely need to go into our sample space over here and take a look at which outcomes will be, falling under that. Let's make this guy a little bit bigger. So we're talking about a sum of greater than or equal to 7. So can you tell me how many of these outcomes will satisfy that?
Can you scroll up just a little bit, please?
I may have to make this smaller. Hold on. Is that good?
Yes, thank you.
Okay. So a sum of greater than or equal to 7. And Brooks, I did see your answer. So again, you are rolling 6-sided dice, right? So those would be your possible outcomes. And then when you start adding those numbers together, we're talking about equal to 7, which would of course be these guys over here, where you can see the total comes out to be 7. So all of these would be equal to 7. And you can see those are coming out to be 6 out of 36 possible outcomes. So that's going to be this probability right over here. Then we are talking about also the numbers that are greater than 7. So your sum is greater than 7, which would of course then include all the 8s, all the 9s, 10s, of course, anything that is larger than 7. The 10s, the 11s, and the 12s. So you can see those guys are then coming out to be, so we had 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So you've got a total of 21 events out of 36. And that's the number, Brooks, you shared with me. So yeah, that was great. So you can see those are the total outcomes which will satisfy this. And that's what you are looking for. So what is going to be the probability that you get a sum which will be 7 or basically greater than 7? And again, anytime you are working with fractions, guys, remember you need to reduce your fraction down. And I think I saw, Terry, you shared that answer with me. So you can see between 21 and 36, what number will be common that we can reduce this fraction by?
3.
3, yeah, very nice. So 21 divided by 3 gives us 7. 36 divided by 3, of course, gives us 12. And then you can see this is as far low as you can go. So that's the answer you are looking for, 7 out of 12. So remember, sometimes just doing a simple sample space can help you out, and you can come up with, okay, how many outcomes satisfy, what condition or events I'm looking for, and then break it down into, fraction, decimal, or percentage that you can do. So let's go back over here. So in this one, that will be a total of 21 out of 36, which reduces down to 7 out of 12. And then, again, guys, if they ask you, especially like in my open maths, do they want, decimals? Do they want fraction? Do they want percentage? You can change it accordingly. So if you wanted to change the 7 out of 12 into a decimal or a percentage, just go ahead and divide that fraction. 7 divided by 12, you can see it comes out to be 0.583333, repeating. If you wanted to change this to a percentage, multiply it by 100, and you get 58.33333%. Yeah, exactly, Brooks. And Terry, I see your answer in there also. So yeah, very good. So just look at the instructions on, how they want you to write these answers out. So we'll go ahead and put our decimal answer and then our percentage answer. Alrighty. So using that same idea, now let me see, what can we say about the probability for part B? Getting an even sum or a sum greater than 7. So getting an even sum or a sum greater than 7. So again, we'll go back to our sample space. And what do you think this probability should come out to be? So take a minute or two, look through the options, and let's see what your probability comes out to be. Even sum or sum greater than 7. Okay, Brooks, I see your answer. Terry, I see your answer. Go ahead and reduce your fraction and let's see what that comes out to be. Okay. So again, the events you are looking for is it should be even sum or a sum greater than 7. Okay, so I've got Brooks, Terry, Michael, so Sarah and Sabrina. Let's see what you guys are coming up with. Oh, okay. Sorry about that, Sabrina. Okay, Sarah, go ahead and reduce your fraction, and what would that look like? Yeah, so find what's common between the numbers, yeah, and divide both of them by that. Okay, Sarah, I got your answer. So when we're talking about even sum, which events did you guys use for that? When it says even sum. Yeah, very nice, Terry. So basically it's going to be where your total comes out to be all the even numbers, right? So that should be a total of 2. Of course, your 4s, your 6s, the 8s, and then of course the 10 and the 12.
I didn't do
So
that.
this is where all of these sums, your total, were even numbers, right? So those would be all of these events over here. Okay, Sabrina, I see your answer. Brooks, very nice. Use the even answer, Sarah. Okay, very good. And then Terry, I think you said 2, 4, and 6. Michael, you had 1/2 in there. Okay. Now, the other part of this is saying, so that's the even sum. And then the other part of this is saying all the sum that was greater than 7. So that was the second part, or sum greater than 7. So remember, in this one, they're just saying greater than 7, right? So nothing is including equal to 7, like you had in part A. So this is going to be a little bit different. So greater than 7, of course, again, you would be doing the 8s. But since you're already counting them over here, you don't need to repeat them for the second part. But then greater than 7 would also, of course, include the 9s. Again, you're already counting the 10s. And then you would also include the 11s and the 12s in there. Now, you don't want to repeat the numbers. Whatever is already been counted as part of the even sum, do not count them again as greater than 7. So definitely don't want to use the repetition in there. And let me see, Sabrina, what did you say here? Okay, so Sabrina, you're basically saying you added the events to 6, so there was no repeating, and I could add the 9/36 to the greater than 7, but you included the 7th. Yeah, and you don't want to include the 7. Very true. Yeah, leave those 7s out because they're not asking us to for anything that is equal to 7, right? So when you count all those blue and red circles together, that should tell you how many total events we have. So it looks like we've got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So it's actually going to be 24 out of 36. And I know the most common answer I got was, I believe, 30 out of 36. I think 3 of you gave me, actually 4 of you gave me that answer, which reduced down to, of course, 5/6, right? Because when you divided it by 6. So again, you can see how many total circles we have. That's adding up to 24. And then between 24 and 36, 12 will be a common factor. So 24 divided by 12 gives us 2. 36 divided by 12, of course, gives us 3. So this guy actually comes out to be 2/3. Any question on like where the error happened or anything that did not make sense, especially those of you who ended up with 30 out of 36?
Sorry, I didn't realize I wasn't muted. So we're just looking to see how we add everything on the OR together.
Yeah, so remember the OR, the way it works is either this or that, or both of them together, right? Because this is an inclusive or. So that means you're taking all the even sums, you're taking all the sums greater than 7 and putting them together. The only difference is going to be no repetition, right? So like those circles that I had circled in red and blue, you don't want to count them twice, you only count them once. And that's the only thing I can think of for those of you who came up with 30 was that you just didn't realize some of those outcomes were being counted, in both categories, and we didn't need to count them twice. Okay, Sabrina, I'm glad to see that. Okay. Sarah, very good. Yeah, all righty. So let's go ahead, transfer this over here. So this should be, let's see, 24 out of 36 is what we started out with, which reduced down to 2/3, which of course then comes out to be 0.66666 repeating, which will be 66.67%. Alrighty, guys, so that was number 8. Now for the next one, I had number 12 selected. So let's come back down here. Alrighty, so number 12 is talking about a box of chocolates contain 7 dark chocolate pieces and 3 milk chocolate pieces and no others. If you randomly pick 2 pieces and eat each chocolate after choosing it, what is the probability of choosing at least one dark chocolate, right? The probability in all 3 forms. Okay, so they're telling you how many dark chocolate and milk chocolate pieces we have. They're also telling you those are the only 2 types of chocolates in there. So that way, we don't think about, oh, what if there's like white chocolate or, something in there, which I don't know if white chocolate is really chocolate. So now they're saying if you pick 2 pieces randomly, what is the probability that at least one of them would be a dark chocolate? And then of course, all 3 forms would be fraction, decimal, percentage. That's what they mean by all 3 forms. So in this case, where do you think we should start out first to figure out the probabilities? What would be step 1, I guess? And while I am waiting for your answer, yeah, Terry, very nice. Start by adding the total of all the chocolates. And what does that total come out to be, guys? Yeah, very nice, Sarah, Terry, very good. So yeah, you've got 7 dark chocolate and you've got 3 milk chocolate, right? Michael, very good. So yeah, 7 plus 3 will add up to a total of 10 chocolates. Okay, so we've got a total of 10. Now the idea is they're saying, what if you randomly pick 2 chocolates and what are the chances that one of them is going to be a dark chocolate? So anytime they talk about, at least, with a probability that at least one of them is such and such, for any of these at least type of examples, you actually want to use the probability of a complement of an event. So just to show you that, and that's kind of what I was scrolling through up here initially, was just to show you what that probability of a complement looks like. So remember, we had kind of talked about, sometimes it's easier to do the negation, part of the, oh, that terminology is just skipping my brain. the negation of an event instead of, trying to directly find what the probability is going to be. So we're actually going to do this one over here, where we're going to use 1 minus the probability of, what we're trying to find. Sabrina, exactly. So you are trying to find what is the probability of getting dark chocolate. So if I had to rewrite this guy, so we're trying to figure out what is the probability that we get at least one dark chocolate, but we're going to calculate it by doing 1 minus the probability that we did not get a dark chocolate. So that's how we're going to calculate this over here. So the first thing we're actually going to have to do is talk about what the probability of each of the types of chocolate is. So we had 7, and let's go back over here. So we had 7, which were dark chocolates, and 3, which were milk chocolates, right? So your probability that you are going to end up with dark chocolate is going to be 7 out of 10, right? Because our total pieces are 10 in this case. And then the probability that we get milk chocolate obviously will be the 3 out of 10. So when we are talking about at least randomly picking 2 chocolates over here, and I'm trying to think about this one. Probability that we are picking 2 chocolates. So 7 out of 10 would be, hold on. So 7 out of 10 would be, if you were just asking, okay, you have a total of 10 chocolates in the bag, 7 of them are dark, 3 of them are milk. What's the probability that you choose, dark chocolate, which would be 7 out of 10. But we are talking about you are randomly selecting 2 pieces of chocolate. And then out of that, we are asking, what is the chance that at least one of them would be a dark chocolate? And you're not putting them back because they specifically are telling you that you are eating each chocolate after choosing it, right? So this is definitely not going to be independent events, right? Because remember how we were talking about dependent, independent events? And I'm trying to keep my writing so that I can, use it as we are moving forward. So I apologize for all that writing over, but this is where we are going, the without replacement part, this paragraph right over here, because since you are choosing the chocolate and you eat it, your probability will keep changing. So Sabrina, you mentioned that in the chat, because yeah, you're starting out with 7 out of 10 initially, but then once you pick that first chocolate and you eat it, your next probability will change by 1 and it will drop down to well, technically it can drop down to 6 out of 9, or it could also drop down to 2 out of 9, right? Depending on, are you looking at milk chocolate or dark chocolate? We're of course only interested in the dark chocolate part. So let's take a look at how this will change. So let's come back over here. Okay. So let's talk about finding the probability that you are not choosing a dark chocolate. How would you set that up? Not choosing dark chocolate, which automatically means you're getting a milk chocolate. Terry, very good. Yeah, the first part would be 3 out of 10, which is this one over here. And then what happens the second time that you pick a candy again or chocolate again? Sarah, yeah, the first one will be 3 out of 10. Okay, so Sarah, Terry, I see your answer there. Sarah, you are saying if you selected both milk chocolate first time, or 1 out of 8. Okay, I think Sarah, what you are doing is 3 minus 2 and 10 minus 2, right? To get the 1 minus the 1 over 8. So you're kind of going with what if you selected both milk chocolates for each of your candy. Okay. Sabrina, you actually multiply them. You're not adding them. Okay, guys, so let's take a look at this. So we are saying basically we want to find out what is the probability that we did not select the dark chocolate, which automatically means since there's only 2 types of chocolates, there's no other, type in there, you're choosing milk chocolate. So that would be 3 out of 10 for the first time. So on your first try, and then on the second one, you would drop this down by 1. So because you ate that chocolate, so this drops down to 2 out of 9 now, and you will end up multiplying these 2 numbers, which of course 3 times 2 will give us 6, and then of course 10 times 9 will give us 90. So that is going to be your probability that you did not select a dark chocolate, and then you would end up doing 1 minus 6 out of 90 to get your probability of the dark chocolate. So what do you think this will come out to be when you do 1 minus 6 out of 90? Okay, I'm seeing some answers come through. Michael, you can actually reduce that fraction even further. So I'm going to show you that math over here. So we are doing 1 minus 6 out of 90. Okay, Michael, very nice. So remember, the first thing they want us to do is, obviously you're writing your answers in all 3 forms. So we will need to know what this looks like as a fraction, and then of course as a decimal and percentage. Now, if you guys are comfortable doing this on a calculator and getting all 3 forms of your answer, that's totally fine. But just to show you guys, when you are trying to break this fraction down, so you're doing 1 minus 6 over 90. So, you will need to find a common denominator, which means we would end up multiplying this side over here by 90. So we can rewrite that 1 as 90 over 90. And then you are subtracting the 6 over 90 from that. So of course, 90 minus 6 will give you 84. 84 out of 90. And then of course, you want to break this down as far as you can go. So let's see. Okay, I was trying to do it by 9, but that doesn't seem to go in there. And you've already shared your fractions with me. Michael, why do you only have 1 out of 15? Okay, just
wrong fraction.
Oh, okay. So this is what you should be ending up with. And then, of course, we can reduce this down further by 2. So of course, 28 divided by 2 will give us 14. 30 divided by 2 will give us 15. So that should be your reduced fraction in there. Okay, Michael, I just realized what you did there. Okay. So 14 out of 15 should be in the lowest form. And then, of course, we will convert that into decimal and percentage. So just to kind of recap what we're talking about here. So you are starting out by looking at each individual probability. So just about talking about, okay, we have a total of 10 chocolates. 7 out of the 10 are dark chocolate. So that's our probability for the dark chocolate. For the milk chocolate, it's going to be 3 out of 10. But then because you are eating the candy as you move forward, for the second attempt, this guy will end up becoming, sorry, 2 out of 9 the second time you pick a candy. So you end up multiplying 3 times 3 over 10 times 2 over 9, which actually then ends up becoming what did we have? 6 over 90. And then to calculate your probability for at least one of them being a dark chocolate, this is where we use the probability of a complement. So that would be the 1 minus 6 over 90, which then comes out to be, as you saw in our arithmetic over here, 84 over 90, which will then reduce down to 14 over 15. And then, of course, we can convert that into decimal. And what will that look like as a decimal? 14 divided by 15. Okay, so 0.933333 repeating. And then, of course, as a percentage, that would be 93.33%. And you can see that's what this math will come out to be. So just a little bit of a different, and like I was telling you earlier, look for that term, which is saying, what is the probability of choosing at least one dark chocolate? Whenever they talk about an at least probability, you kind of automatically want to do the complement, of an event to calculate this, because this is a lot more easier than trying to go, the direct route, which would be, okay, so my probability for the first attempt would be what? And then my probability for the second attempt would be what? And then trying to put that together. So trust me, this one goes a lot better to do the complement of an event than trying to go through the direct route. So I see 2 of you have raised hands. Michael, Terry, whoever wants to go first, go ahead.
I'm curious if this is the same question that I was having difficulties with the percentage.
No, the one you had was basically you just had to multiply, because I think, and I know I saw that question last night. I think they were saying if you choose 2 items randomly, but they were not asking you for an at least probability. So all you had to do was take your percentage that was given to you and multiply it into itself 2 times, because you did not have to worry about replacements, if you were replacing an item or not. So you had a pretty straightforward question. You would just take the probability you had and just multiply it into itself, because you were choosing whatever the event was twice. Yeah, so you don't have to worry about doing the complement. So the way the complement works is you literally are looking for that keyword of at least to try and use this probability. Michael, you also had your hand raised?
I think I just forgot to put it down since the beginning of class.
Oh, that was the one. Okay, and then Sabrina, I saw you sent a message. So this is Sabrina, honestly, this is the most direct way of solving a problem of this nature. So I would say for questions like number 12, this is your direct route of figuring out what that probability is going to be. There are other ways of solving it, but they would be more complicated than the way I showed you right now. And yeah, you will see questions like this on your homework and in your test for sure. Okay. Alrighty, guys. So that was using the complementary event. Now let's look at one more example. Oops, sorry. Number 14, yeah. You will see stuff like this in your homework, yes, for sure. Okay, guys, so something similar to what we just did, but of course, the probability is going to look a little bit different. So the same idea over here that, you have a bag or a container with different items in there, and then how to calculate your probability. So as you can see, this one is saying a bag contains 3 green marbles, 4 red marbles, 5 blue marbles, and again, there's nothing else outside of these 3 colors. If you randomly pull out a marble and put the marble back 3 times, so you will see in this case, you are replacing it, right? You're putting the marble back. So this is with replacement. What is the probability that you pull out a blue marble all 3 times? And again, you're writing this in all 3 forms, your probability. So let's talk about what's our total in this example here. So what's your total quantity in the bag? Yeah, Michael, very nice. You're doing 3 plus 4, which is 7. 7 plus 5 will put you at 12. So we have a total of 12 marbles. So let's talk about, since you are doing this with replacement, what would that look like? So again, just to go back up to our independent and dependent events, when we are talking about with replacement, you're looking at this guy over here. So your events will be independent because you are replacing the item that you take out of the bag. And so just like we did with the chocolate example, and that was the one without replacement, since we were eating that piece of chocolate, it changed our probability as you were going from ones to the second to the third. But when you're talking about with replacement, remember your probability will stay the same because now you're not dependent on what you drew the first time around. So that's going to be the difference in this example over here. So let's come back over here. So let's talk about what will be, just without getting into the question right now, just looking at that first sentence, what will be the probability that we choose a green marble? How would you write that first one out? So forget about the question that the problem is asking. Right now, I just want to know what's the probability that we could select a green marble. Harry, is that what you meant? Okay, I was going to say that does not look right. Okay, very good. Michael, I see your answer in there. Very nice. Yeah, so we've got a total of 12 marbles. 3 out of those 12 are going to be green, right? So that's the probability of green marbles. And then when you reduce this fraction, guys, what will you have? Yeah, so anytime you are working with fractions, remember to put them in the lowest form. Now, having said that, once we get into the question, I might change my mind, but we'll get there. Probability of selecting red marbles? Yeah, very nice, guys. So that would be, of course, again, 4 out of 12, which when you reduce that, this will reduce down to 1/3. And then the last one, what's the probability we could select blue marbles? Terry, very nice. And this one, we cannot reduce it, right? Because Sabrina, very good, because obviously 5 will not go into 12 evenly. So you can leave that as 5/12. So now the question is, as we keep moving forward, what is the probability that we could actually end up choosing blue marbles all 3 times? They're telling us you choose a marble, you basically, of course, noting its color, but then you put it back into the bag. So walk me through for each possibility, what would our numbers look like? The first time, the second time, and the third time. Sabrina, I believe you are on the right track. I haven't solved these problems, so I don't have the answers written down. But from what I'm seeing of the numbers, that definitely looks promising. Yeah, so Sabrina, you said taking the 5/12 because we're interested in how many of those would be, blue marbles. So that's the probability multiplied into itself 3 times. Very good. So we want to know what's the possibility that all 3 times you end up with a blue marble. So you take that probability for the blue marble and multiply it into itself 3 times. So you're doing 5 times 5 times 5 on the numerator. So 5 times 5 times 5, of course, is going to be, and let me write that down a little bit better. So you're basically taking 5 12s, multiplying it into 5 12s, multiplying it into 5 12s, because they're telling you you are doing this 3 times. And that's why you multiply it into 3 times. So yeah, 5 times 5 is 25. 25 times 5 is 125. 12 times 12 is, of course, 144. And then 144 times 12. Yeah, Sabrina and Terry, that looks good. Will come out to be 125 out of 1728. Now, of course, you can see 5 doesn't go into, Michael, very good, into 12. So 125 will also not go evenly into 1728. So that's what we will end up with. And then let's see as decimal, what will this look like? And looks like, Sabrina, you already have your decimal answer in there. Very nice. So this is going to be 0.07233796. I'm just putting all the digits that I'm seeing in my calculator. So 0.072337963, and then of course as a percentage that would be 7.23. Terry, you just had a slightly higher number there.
Yeah, I figured it out. I did it wrong in the calculators.
Okay. So you can see again, guys, just the difference between number 12 and number 14. And the big part of that was you did not have any replacement, since, you picked the chocolate and you ate it. You were not putting the chocolate back into the bag. And that's why it changed your probability. But here, because you are replacing the marble back, and since you are putting it back, that changes the way you do probability. So that's kind of the difference that I wanted you to see between the 2 types of probabilities. So question on either 12 or 14.
Question about when it says at least, that means there's no replacement?
No, at least means you are using the probability of a complement. So the at least would mean you are using this formula.
Okay.
And this was oh good Lord, there it goes. Yeah, so that means you would be using the complement of an event formula to find that probability. Anybody else? Any other question on this, guys? Okay. Okay, just to kind of change it up, let's look at number 15. So obviously you can see it's kind of set up the same way as 14, but the question is a little bit different. So again, you've got bags containing 3 blue marbles, 4 red marbles, 5 blue, and no other. If you randomly pull out 3 marbles all at once, what is the probability that you choose at least 1 blue marble? And since you're doing 5, 4, and 3, of course, your total will still come out to be 12. And they want to know what is the probability that at least one of them would be a blue marble.
When it says all three forms, does it mean fraction, decimal, and percent?
Say that again, Michael?
When it says write the probability in all three forms, does it mean fraction, decimal, and percent?
Yes, exactly. Yeah. So take a minute, think about this. Again, you should notice the terminology of the at least. So that means if you're trying to find what is the probability that you would choose a blue marble, this would be the same thing, 1 minus the probability that you did not pick a blue marble. So just to write those probabilities out again, the probability that you choose a green marble would be 3 out of 12. Probability you choose a red marble would be 4 out of 12. And probability you choose a blue marble would, of course, be 5 out of 12. And again, this guy would be what, 1/4, and this guy would be 1/3. So first you want to think about, okay, so how would I figure out what is the probability that we did not choose a single blue marble? How would we write this guy out? First, think about that. Harry, very nice. Yeah. So now think about, okay, so how can we write this out? Yeah, Sabrina, very good. So yeah, exactly. When we're talking about the probability that we do not choose a blue marble, which automatically means it could be red or it could be green, right? So that's 3 plus 4, which would be 7 out of 12. Now we are still talking about choosing all 3 marbles at the same time. So choosing all 3 marbles at once, you know, how would you go about and do that probability then? Do we do it with replacement? Do we do it without replacement? How would you go about kind of breaking that down? Okay, Michael is saying that we should think about this as without replacement. What do you guys think? Sabrina, you said no replacement. Terry, you also said no replacement. Yeah, because if you're choosing all 3 marbles at once, that obviously means you're not putting them back, right? It's not like you pick one, choose the color, you know, write the color and put it back. So definitely not replacement. So what do you think that probability will come out to be for those 3 marbles that you're selecting? How would you write that down? So the first time you would do it, Sabrina, that is perfect. Very nice. So the first time you do it, you would definitely do 7 out of 12, right? Because we've got all the marbles in there. That would be for the first marble. The second one, and since there's no replacement, that will go down to Terry. Perfect. Very nice, guys. I am so impressed. that would be one less, right? So 6 out of 11 now. And then for the last one, the third time you do it, of course, you go down by one more again. So that would be 5 out of 10. And whatever this number comes out to be, let's see, 7 times 6 times 5. And then, of course, 12 times 11 times 10. Okay, so that should be 1320. So now you are doing 1 minus, this number over here. So that would look like 1 minus the 210 minus 1320. And what will that come out to be? So that will come out to be 1110 out of 1320. And then, of course, we can reduce that down to decimals and percentage. So what are you looking at this guy in terms of decimal and percentage? And remember again, the way I showed it to you when we were doing the last calculation, you can think of this as being 1 over 1. To find your common denominator, you would multiply this by 1320, which would then, of course, come out to be 1320 minus 210, which is how I got this numerator. So 1320 minus 210 will give you the 1110, and then divide that by 1320. And what kind of decimal answer are we looking at? Yeah, very nice, Terry. You're giving me the reduced fraction here. So just remove that extra 0 at the end. Which I don't think there's anything common between 132 and 111. Is there? 37 out of 44. Ah, okay, yeah, 3 will be common. Sabrina, very nice. So you had okay, yeah. Okay, there we go. Still looking for the decimal and percentage answer here, guys.
How many places should we reduce the decimal to?
I would say at least keep it to maybe 3 or 4 decimal places in the decimal answer itself. And then percentage, after you convert it, 2 decimal places.
Okay.
Yeah. Okay, Michael, if you're doing any one of these fractions, 1110 over 1320, or even 37 out of 44, that should not be your decimal answer. Terry, Sabrina, yeah, that looks good. Very nice. So as a decimal, you should end up with 0.8409, and it keeps going. And then as a percentage, that would of course come out to be 84.09%. Yeah, Michael, very nice. So again, just to show you, whenever they are talking about that, at least, as part of your probability, again, you are using the complement of an event probability to figure that out. So that's kind of what you are breaking this down as. Okay, anybody have questions on this one here? Brooks, Sarah, I haven't heard from you guys. Are you doing okay on this? Yeah, Sabrina, no worries. You're welcome. Alrighty, guys. So this was kind of the end. Okay. Sarah, if you have time and you want to stay back after class, you can do that also. If you want to ask me some questions, we can definitely help you out if you wanted to. So again, guys, remember you are only doing these two sections from section 4.1. So you have 4.1 and 4.2, and then I also went ahead and opened up your practice for this one. So your practice is also available. Now, the one thing that I wanted to talk to you guys about was we actually do need to at least have a brief discussion on linear and exponential models. And we need to talk about direct and inverse variation. Yeah, Sarah, I'm just getting ready to talk about that, okay? No worries. So as I was saying, only two sections from chapter 4, you've got your practice in there. We are actually not going to take the exam during class time. So as I was saying, we have, and let me actually go ahead and stop sharing this. So we have to talk about, like I said, even though it's just introduction, I do want to talk about linear and exponential models. And then we have to talk about direct and inverse variation. So I was thinking this will be the exam you guys can do at home at your own time. I'll give you about 24 hours to work on it. So, take your time. Do the exam so we can use the class time to just talk about the linear and exponential models, do the direct variation and inverse variation discussion. And so that way, we can then at least, I would like to have at least one day where we can review for the final. So instead of doing an in-class exam and using up a class time, let's, keep one class session as a review session. And so that way you can do the exam at home. And, it's 2 sections. It's probably not going to be a very big exam, as you can imagine. I would say maybe 1 hour tops is what you would need to take the exam. And I'm confident you guys can do that on your own. If you get stuck on anything, you have questions, I'll be glad to answer any of those for you. But for the chapter 4 exam, we'll do that as an outside class exam. And then we're just going to use, we've got 5 more class days. One of them will be for the final exam. So 4 more class days. Let's use that to wrap up what we need to, and then use one of those days as review. So will you guys be okay with that? Does that sound all right? Yeah.
Yes. When will the exam be open and when will it be due?
Wednesday.
Wednesday. Okay.
Yeah.
It'll be
Um,
open Wednesday.
I'm trying to think. I want to give you guys 24 hours to do it. So do you want to do it from like 11 a.m. to 11 a.m. kind of thing? Would that be okay?
That sounds good to me, if it's
Yeah.
good with everyone else.
Michael, were you going to say something?
It opens Wednesday at 11 a.m. and then it'll close Thursday at 11
Thursday at 11. Yeah.
That makes sense.
Yeah. Not like 11 a.m. to 11 p.m., but 11 a.m. to 11 a.m. So yeah, and like I said, since it's only 2 sections, I'm kind of hoping, it'll be a short exam. I'll start working on it today. I actually haven't had a chance to work on it since I was trying to wrap up all the other grading I had. But I will go ahead and get that done. Your practice exam, for the chapter 4, you will see only has 29 questions. And obviously your exam is not going to have all 29 of them. I would say maybe half of that. So it will not be a very big exam. Few questions from 4.1, few from 4.2, and you're pretty much done. So work through your homework for 4.1, 4.2. I know most of you are actually almost done with 4.2 when I checked last, but if anything comes across you are not comfortable working on it, let me know and I'll be glad to answer any of the questions for you. But that's kind of our plan going forward, guys, for this week and next week. So your exam is scheduled for Friday, the 9th, which is, officially the last day of our class. I'm hoping to use the Wednesday before that, which would be December 7th, as a review day. And then between Wednesday and Friday this week and Monday of next week, we should be able to wrap up the last part with the linear and exponential functions and direct variation, inverse variation. So I think we are looking good as far as the semester coming to an end goes. Sabrina, yeah, you will be tested on pretty much everything we've done from day 1 to day whatever, 28, 29, wherever we're at for the last one. So because it is a comprehensive final, you will definitely have everything from the beginning to the end. So that will also include the stuff that we're going to get ready to talk about here in the next 3 classes also. So all of that will be put together. Now, what I will go ahead and do is I will reopen all of your practice exams, from the beginning. So you will not see a specific review for the final, because since we already have these practice for all the other chapters, I'll just go ahead and open all of those older practice. So use that as your review for the final exam. And then, as we get closer to finishing about the new material, we can start talking about what your final exam will look like. But that's kind of where we're headed, guys. So if you have any specific questions about it, let me know. But that's kind of just give you a heads up of just basically what's coming here for this week and next week. Yeah, Michael?
Will the final exam be timed?
Final exam will be timed, yeah.
And also, when will we get like our final grade for everything back?
Probably not on the 9th itself. Like for the other material and stuff, I'll start updating your grades in D2L and my open math. I'm not sure what my open math will allow me to do or not do, but definitely in D2L. And then for your entire semester grade, I would probably say that following Monday after the 9th, which will be what, the 13th? No, I think I'm saying that wrong, aren't I? Whatever is that Monday after 12th, sorry. Monday the 12th I would say somewhere around there is where I should be able to get all your final grades in.
Awesome.
Yeah. Sarah, unfortunately, I am not sure how many questions will be on the final test. Once I start planning and looking at it, I will probably have a better idea, but at this point, I'm not really sure. And I don't want to give you like a wrong number either. But hopefully here in the next couple classes, I should be able to give you a better idea on that.
Okay, thank you.
Yeah, you're welcome. Any other questions coming to mind, guys?
I have one question about that problem. That's all.
Okay. Okay.
It was way too simple. I made it way too complicated in my head. So if say it was 3 people that would have gotten a dog or no dog, then it would have just been 49% times 49% times 49%, right?
Very good. Yeah.
Okay.
Yeah, sometimes they sound like they should be more complicated than what they are, but it's just and that's kind of the thing about probabilities is once you start kind of working through the examples, you get confident at it, but in the beginning it seems like, oh, do I need to go like with the complement of an event, or do I need to do a straightforward calculation? And that's why I was pointing out to that at least terminology, because if you see the at least as part of that question, then you're definitely using the complement of an event. And then, of course, look for the keywords like, is this an and probability, or is this an or probability? And then when you're working with and, you are thinking about, are these independent or dependent events? With the or, you are thinking about, are these overlapping or are these disjoint events? Because, you know, that's how then the little calculation will change. So those would be kind of some of the things to watch out for as you're looking through these probabilities.
Okay, thank you.
Okay, yeah, you're welcome. So if you guys want to stay back and ask me any more questions, guys, I'll stay back, but if not, I will see all of you on Wednesday.
Thank you. See you Wednesday.
See you Wednesday. Thank you. Sabrina? No, I did finish those and I will go ahead and start sending you your grades and your link to the file again, because I think that link expires, so you guys are not able to access it, but I'll go back and send you the link with your grades so you can kind of see my comments and stuff that I put in there.